Hi, welcome to Lab 3, Black Hole Mass. In this lab, we are given the data position points of a star of mass 2.1 times 10 to the 27th kilograms. Using these position points, we are supposed to determine the mass of a black hole using Newton's law of gravitation and our knowledge of the principle of momentum. I did this using the VIDLE program on Python and determined the mass of the black hole to be 3.939 times 10 to the 31st. The initial conditions given for this lab were the star's mass, we used the time step of a year, the black hole's position, and also the vector position of the star given in the star data CSV file. We assume that the star is the system and the net force on the star is due solely to the gravitational force of the black hole, and the black hole is also not moving. Using these, we are allowed to use the law of gravitation to determine the mass of the black hole. We know that when the path of an object curves, like the elliptical path of the star around the black hole, that the object's momentum is continually changing. Therefore, the object's net force is continually changing. To determine the net force, we use the momentum principle and eventually the law of gravitation to determine the object's mass. The object in this case is the black hole. Here's my tracker code for the black hole data. You can see that V initial and V final are based on the position vectors of the star's individual points, and then the initial momentum and final momentum are based on the initial and final velocity determined earlier, multiplied by the star's mass, and consequently we can calculate the change in velocity and the change in momentum. Using these, I determined the derivative or the rate of change of momentum, and using the rate of change of momentum and the principle of momentum, we found out the net force, the parallel net force, and the perpendicular net. After I used these net forces to determine the black hole mass. I did this by calculating the radius, by calculating the magnitude of the difference between the star position vector and the black hole's location, and also I plugged in the constant for g, and then the black hole mass was calculated by using Newton's law of gravitation, as you can see, using the magnitude of the net force multiplied by the radius squared divided by constant g and the star's mass. Now, because at each position point the radius changed because the star's orbit around the black hole is not necessarily a circle, the net force at each point was different, and so to calculate the average or the black hole's mass, I determined the average of all of these masses determined by net forces. Here you can see my program running through Tracker, and you can see that the force arrows get larger as the star increases in proximity to the black hole, and as they get smaller as it decreases in proximity. You can also see later here the average of all of the masses calculated based on the net force for each data point. Though we use the rate of change of momentum to determine F net in the given problem, though the magnitude and the momentum principle states that these two vectors are equal to each other, we know that they're not. In fact, we could say that the momentum change is caused by the net force. If the mass of the black hole changed or a new black hole was put in place, because the only force acting on the star is that of the gravitational force based on the black hole, we know that the only change would occur because of the change in mass. So if the position didn't change, that means the mass is the same.